Slab-on-grade foundations come in two main types: independent slabs separate from the foundation, and monolithic slabs connected to thickened edge footings. Understanding moisture control for these two systems is simpler than basement construction, but the same fundamental principles apply. Slab-on-grade construction works best on relatively flat sites and low-lying areas prone to ponding. Maybe a crawlspace foundation would be a better choice. For example, Florida uses slab-on-grade homes, while Raleigh, North Carolina typically uses crawlspaces due to 4 feet of annual rainfall that creates wet ground conditions. And here's the 8-inch rule. Slab-on-grade foundations require minimum 8-inch clearance above exterior finished grade. In heavy rainfall areas, greater clearances or additional rain control measures may be needed. The foundation pad must be properly mounted with structural fill, and fills over 12 inches typically require engineering. A simple test: the pad should support a loaded dump truck with less than half-inch depression. A 6 mil polyethylene vapor retarder is generally required below habitable space slabs, with 6-inch minimum lap joints in direct contact with the slab underside. This prevents moisture vapor from adding to the interior moisture loads and breaks the capillary moisture movement from the ground. A 4-inch layer of clean, graded sand, gravel, or crushed stone provides the capillary break that prevents bulk soil moisture from wicking up to the slab bottom. This layer goes under the vapor retarder, so water can't be trapped between the barrier and the slab. Concrete will crack during curing. That's normal. Welded wire fabric reinforcement controls crack severity, while concrete control joints create planned weakness lines to control the random cracking. Horizontal number 5 rebar at the top and bottom of thickened edges allows the footing to act like a reinforced grade beam, reducing differential settlement cracking. Exterior foundation insulation on the vertical outside face minimizes thermal bridges and maximizes energy efficiency and moderates slab surface temperature to prevent condensation. Frost-protected shallow foundations, FPSF, use insulation to raise frost depth around the buildings, allowing shallower footings in cold climates. Effective slab-on-grade moisture control combines proper site grading, adequate foundation elevation, vapor retarders, capillary breaks, and crack control, and each component supports the others. You miss one element, and moisture problems can develop even with the other protections in place. During your home inspections, verify adequate foundation clearance, proper site grading away from the structure, and then look for signs of moisture intrusion or settlement cracking. While you can't see the vapor retarder or even the capillary break, understanding these systems can help you do your inspections and diagnose visible moisture problems.